Okay, today we're going to consider trigonometric equations. So first, let's continue from where we left off last time, and think about sine x equals 0.5. But now let's think about it for minus 360 degrees less than or equal to x less than or equal to 360 degrees. So we've extended the range. Now, if we were to put this into our calculator, and if we were to find do the inverse sine of x for 0.5, we'd find x, and we'd find it would be pi over 6, or 30 degrees. But we know, because of the the shape of the sine graph, the sine function, there are more values of x within this range. So let's sketch this, the sine function. So we've got minus 360, we've got minus 180, we've got 0, we've got 180, we've got 360, we've got 270 here, 90, minus 90, and minus 270. And this is 1, and this is minus 1, so half's here. I'm going to change the colour of this to make it show up better. So half is around about here. So we can see this is 30 here, but we also have solutions here, here, and here. So there are 4 solutions. We actually have 4 solutions to sine x equals a half for minus 360, between the minus 360 and 360. And the solutions will be minus 330 degrees, minus 210 degrees, over 30 degrees, and 150 degrees. And we get that by, if you think about here, 180 minus 30 is going to be the 150. And here, if we do minus 360 plus 30, we get the 210, and plus 30 again, and we get the 330 minus 330, and then plus 30 again, we get the 210. Sorry, no, we don't. Plus 100 minus 180 plus the 30, we get the 210. So we can tell by looking at it in the symmetry of the graph, these are the points that we are interested in. Now, let's look at another example. So if we're going to solve cosine x equals minus 0.7. Now this time we're going to be looking at the values of x between 0 and 360. So when you see a question like this, you're going to solve a trigonometric function, you really have to pay attention to the range of values that we are, the domain in which we want to consider. So if we were to put this into our calculator, cosine x is minus 0.7. We find the inverse of the cosine, we get 134.4 degrees. Now I'm just going to draw a wee sketch. And we'll get our, and let's just have a wee look at, so it's minus 0.7, so round about here. So again we have these two values of x, so this must be 134.4 degrees, and so we need to find this other value. And only just this is 90, this is 270, and this is 180. So if we consider 360 minus 134, we'll get 225.6, and so this here is our second value because of the symmetry of the function. So x must be 134.4 degrees or 225.6 degrees. Let's consider another one. This time we're going to do a tan function. So if we want to find the we're going to solve tan. It's a bit more tricky. 2a equal to minus 2.1 for a between 0 degrees and 180 degrees. So let's make 2a equal to x. So for tan x equals to minus 2.1, put it into the calculator, find the inverse tangent of that, we'd get x is equal to minus 64.56 degrees. Now let's just draw our tan function. Now tan is really important to remember where we get these points where it is undefined. So this is at 90 and 270. So we want from 0 to 180, which is here. And we know that this x is at minus 64, so about here. So this is minus 64.54 degrees, and this will be minus 90 here. So it's about here, and so we've got there'll be another solution before the 100. Here's 180, so we've got a solution here as well. Now, as we can see with the tangent, it repeats every 180 degrees. So the solutions are x equals minus 64.54 degrees, and we have x equals to minus 64.54 plus 180 degrees, which is equal to 115.46 degrees, which is still less than 180, so we're going to have another one. X is equal to 295 point, let's make it clear. So we take this value and then add another 180, which will give us 295.46 degrees. And you can keep, if the domain was larger, you keep going, because the domain is going to, if it was between like 360, for example, you just keep adding 180. Now, this is more than 180, but remember, x is equal to 2a. So 2a is equal to x. So for 2a equal to minus 64.54, we're going to divide a must be equal to minus 32.3 degrees. Likewise here, 2a must be equal to 115.46 degrees, so a must be equal to 57.7 degrees. And similarly, 2a here is equal to 295.46 degrees, so a must be equal to 147.7 degrees. So the solution is 57.7 and 147.7, because it's between 0 and 180, and this one is less than 0. Let's do another one that's a bit more tricky. Let's solve sine of 2a plus pi over 6 equals 0.6 for 0 less than a less than or equal to pi. So again, let x equal 2a plus pi over 6. So now we do sine of x is equal to 0.6, and that will give us a value of 0.6435. Now it's in radians. So bear in mind, just looking at the domain here is in radians, not degrees this time. So again, we're going to do a sketch. And this is pi, this is 2 pi, and for 0.6 is about here. So again, we're going to have two values of x. So this would be 0.6435, and for the second value, x is going to be pi minus 0.635, which is going to be 2.498. Now, remember, 2a plus pi over 6 is equal to x. So, which is equal to 0.4 6, 4, 3, 5. Rearranging all that, we'll get A is equal to half of 0.6435 minus pi over 6, which is equal to 0.0600. And doing it for this value as well, you'd work it all out and you'd get A is equal to 0.987. So this would be the two values for A. Now, we can get trigonometric equations which are more complex, and we can solve them in the same way as we would a function that had x as a variable. But we're going to think of a couple of identities that are really useful. So let's look at this right angled triangle. So we've got some radius, we've got an angle theta, and we're going to call this x and this y. So we know that tan of theta is y over x. Now, what we're going to do is we're going to play with this function. So we can say y, we're going to divide the numerator and denominator by r. So that means y over r over x over r. Now, we know sine of theta is equal to y over r, and we know the cosine of theta is equal to x over r. So this can tell us, if we substitute y over r for sine theta and x over r for cos theta, we find out that tan theta is equal to sine theta over cosine theta. And this is something that's really important that you memorise. And this is for all theta with cosine theta not equal to 0. Now, similarly, x squared plus y squared equals r squared. And we know x squared is x over r squared plus y is over r squared, and that must equal 1. So we've divided, that's by dividing through by r squared. But from up here, x over r is cosine theta, y over r is sine theta, so this means cosine squared theta plus sine squared theta must equal 1. And we'll soon find out this is a really important identity to know, that we can use it in many different situations. And again, this is for all theta. And so we're going to try some examples just to see how we can use these and why they're so powerful and useful. So let's solve 3 cosine squared x minus sine x cosine x equals 0 for 0 less than or equal to x less than or equal to 360. And again, pay attention to the domain. So what we're going to do here is we're going to factorise it, just like we would any other equation. So we've got a cosine here and a cosine there. So let's take cosine out of the equation. And then we'll be left with 3 cosine x minus sine x equals 0. So cosine x equals 0 when x equals to 90 or 270, and we know 3, and so we take 3 cosine x minus sine x equals 0. 3 cosine x must equal sine x. But if we divide both sides by cosine, we'll have 3 equals tan x, because sine x over cosine x equals tan x, and the cosine cancels. So x must be 71.6 degrees or 180 plus 71.6 degrees, which is 251.6 degrees. Oops. Therefore, the solution is x equals 71.6 degrees or 90 degrees or 251.6 degrees or 270 degrees. So we've got these 4 solutions of x. Let's try another one. Now let's just look back at this one here. If this just if this is just quite new to you and you find it hard to grasp it, what to do is go to graphing software and graph this. Have a look at it and find out when is it 0. And you'll find that you get these 4 solutions. So let's now solve 2x sine squared x plus 3 cosine x minus 3 equals 0 for 0 less than or equal to x less than or equal to 2 pi. So when we see this, when you see this this sine squared, let's think about this rule. This rule enables us to take the sine squared x, and write it as 1 minus cosine squared x. And then we've got a function which has no sines in it and just cosine. So let's do that. So we have 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. So let's multiply the bracket out of 2 minus 2 cosine squared x plus 3 cosine x minus 3. So we'll gather like terms just like we would do previously. Cosine x and minus 1 equals 0. Now I'm going to switch signs around just because it's nice to have the squared part of the equation not negative. So it'll be 2 cosine squared x minus 3 cosine x plus 1 equals 0. Now we can solve this like we would any quadratic equation. So we'll have 2 cosine x minus 1 cosine x minus 1 equals 0. So cosine of x must be a half, or 1, and that then gives us x is equal to pi over 3, or 2 pi minus pi over 3. I'll just show you why. Let's just sketch there. So for here's pi over 3, and you get 1 over here as well, which would be 5 pi over 3. So that's equal to 5 pi over 3. And cosine is 1 when x equals 0 or 2 pi. You see x is 1 here and here. This is a half, and this is 1. So the solutions are x equals 0, pi over 3, that's going to be 3, sorry, 5 pi over 3, or 2 pi. So I hope that helps.